Hello and welcome to Module 12 in our series SDL2 with C++. This is the last session for the series, and during this session we will be using the SDL Audio Subsystem. We will also use this session to provide a backdrop for our project. Let's begin by talking about a structure that is pretty important to the SDL Audio Subsystem, and that is the SDL Audio Spec structure. This structure allows us to describe the format of our audio output by setting the values for some of the members of this same structure. Looking at the members now, the first one is integer type frequency, and this relates to the DSP or digital signal processing frequency measured in samples per second. Now, if you're wondering what a sample is, it is a chunk of audio data of the size as specified by a format. And we can select the format through one of the members in this same SDL audio spec structure. That size is then multiplied by the number of channels to give us a frequency. We can also set the number of channels through one of the members of this same SDL audio spec structure. Now coming to the next member, that's SDL audio format type format, and this relates to the format of our audio data. This is the member that will be used to arrive at the frequency. All formats are predefined in the library. The next member is unsigned int 8 type channels, and we can use this member to specify the number of separate sound channels that we have. For example, we could use 1 for mono, 2 for stereo, and accepted values run up to 8, with 8 representing surround sound 7.1. This member also would be used to arrive at the frequency. The next is unsigned int 8 type silence. Now this is the silence value that is written to the audio buffer when audio is paused. Now what that silence value is, we're not really concerned with. This silence value is calculated by another function which we will come to shortly. The next is unsigned int 16 type samples, and this is the size of our audio buffer in samples. The next is unsigned int 32 type size, and this again relates to the size of the audio buffer, but that is in bytes. Finally, we have SDL audio callback, which of course is a function that will be called when our audio device requires more audio data. Now it's important to mention here that both silence value as well as the size of our audio buffer in bytes is calculated by a function, and that function is SDL Open Audio Device. Now, both SDL Open Audio Device and SDL Load Wave require the SDL Audio Spec structure as parameter. Okay, now before we talk about SDL Load Wave, let's talk about SDL Open Audio Device. Now, by its very name, you know that this function is used to open an audio device. It requires certain parameters, of course. The first one is the device itself, and we could pass in a null here to indicate that we would like the default device to be opened. The second is an integer type isCapture, and isCapture is used to represent whether we want the device to be opened for playback or for recording. So for playback, the value to be passed in is a 0, and for recording, the value to be passed in is a non-zero. The next parameter is a constant SDL audio spec type pointer. In other words, desired is a pointer to a structure of SDL audio spec type that holds the desired specifications. The next is an SDL audio spec type pointer again. So what's the difference between the desired pointer and the obtained pointer? The desired pointer, or the structure that is pointed to by the desired pointer, will contain the desired specifications, as I said earlier, and the structure pointed to by the obtained pointer will contain the actual specifications. So how does it work? SDL will look for the specifications that match, or that closely match rather, the desired specifications, and then copy those into the structure pointed to by the obtained pointer, and then of course delete the specifications from the structure pointed to by the desired pointer, right? Now we have the option of not providing an obtained pointer. In other words, we would provide a null in place of the obtained pointer, in which case the desired specifications would become the actual or the working specifications. Next is an integer type allowed changes, and this is how changes, for example, in format are managed. And we normally leave this at 0, allowing these changes to be managed internally. Now, SDL Open Audio Device has a return value, and it returns a device ID on success or a 0 on failure. And of course, we can check for this, and we should check for this in our code. Important to remember that when a device is opened, it starts out by playing silence, right? So how do we get it to play sound? Which brings us to our next function, SDL Pause Audio Device. Now this function is used to pause or unpause audio playback. It requires certain parameters. One is, of course, our device ID. Remember that this device ID is returned by our SDL Open Audio Device function that we saw earlier. The next parameter is an integer type pause on, and this is a parameter through which we specify whether we want the sound to be paused or unpaused. So if we want the sound or the audio to be unpaused, we pass in a 0, and then we pass in a non-zero if we want to pause the sound. Remember that when a device is paused, silence values will be written to the device. This function has no return value, by the way. It's defined as a void function in the library. The next function is SDL Q Audio, and this function is used to feed audio to the device when no callback function is provided. Looking at the parameters, we require, of course, the device ID, which you know now is the return value of our SDL Open Audio Device function, a pointer that contains the data to be queued for later playback on the device. And finally, we have an unsigned int32 type len, which represents the length of the data in bytes. Now remember, with this function, queued data will drain or will be fed to the device as and when necessary without any intervention required on our part. SDL Q Audio will return a 0 on success and a negative error code on failure. Finally, we have the SDL Load Wave function. By its very name, we know that this function is used to load a wave file. Looking at the parameters now, we need to send in the name and path to the file, and then we need to send in a pointer to our SDL audio spec structure. We also need to send in a pointer to our audio buffer. This, of course, would be the buffer that it will be filled with our audio data. And then we need to send in the length of our buffer. SDL load wave will return a true on success and a false on failure. So what does that mean? It just means that SDL load wave is defined as a function that returns a Boolean type, right? Therefore, true on success and false on failure. Now let's write some code. So modify the code so as to introduce sound effects when enemies are eliminated and when the defender is eliminated as well. Also write code to add a backdrop for the project. Before we proceed, may I ask that you leave a like on this video, and if you've enjoyed the series so far, do subscribe to the channel. It not only helps promote the channel, it means a lot to me as well and keeps me motivated to create more content like this. Thank you. Now back to the project. So let's get started. You know what to do. In your Windows search bar, type in BIS. And then from the list of projects, select yours, click once on it to open it up. We'll start in our initialize function. We need to initialize the SDL audio subsystem now. So put in a pipe symbol here and then SDL init audio. Once that is done, let's now proceed to write our function that will handle the sound effects. And I'm going to place it right here. This function is not going to return anything. So void, and the name of the function is going to be load sounds. And what is coming in is the name and path to the file, which is a string. Within this function, we'll start by declaring some variables. So the first one is our unsigned int 8 type pointer, and that will be our audio buffer. The second is an unsigned int 32 type variable for our buffer length. Now for our SDL audio spec structure definition, SDL audio spec, and the variable name is going to be AUD spec, and we just initialize it like that. And then we will set the members. So the first one that we will set is the frequency, and we set that to 48,000. The next we will set is the format, and we will set that to audio S32. Remember, these formats are predefined in the library. Then we set our channels. That's going to be stereo, so 2. And then for samples, we'll set that to 4096. After this, we're going to call SDL load wave. And the reason we've set samples to 4096 is because it's recommended that when you're using or calling SDL load wave, that we set samples to 4096. Now remember, SDL load wave is going to return rather a null if it is unsuccessful, and we will check for that. So if, and then we call SDL load wave, and of course it needs certain arguments. The first one is the name and path to the file, so that's coming through a parameter, and then SDL audio spec, so that's ampersand AUD spec. Then we need our buffer, so ampersand audio buff, and the length as well, so ampersand buff length. Now if load wave returns a null, we need to indicate there's an error and exit. If on the other hand SDL load wave is successful, we will call SDL open audio device. Remember, SDL open audio device is going to return a device ID, and therefore SDL audio device ID type variable has to be declared. Let's call that dev ID, and that will hold the return value of SDL open audio device. And we need to pass in arguments here. So for the device is going to be the default device, therefore null. 0 to indicate playback. Our desired audio specifications, ampersand AUD spec. Now for the obtained specifications, we're going to put in a null so that the desired specifications become the working specifications. And then 0 for allowed changes, to leave changes to be managed internally. Once we have the device ID, then we can use that to call SDLQ audio. Remember, SDLQ audio will return a 0 on success and a negative error code on failure. Let's check for that as well. So that's an integer int. Let's call that success equal to, and that will be SDLQ audio. And arguments to be sent in are our device ID, our audio buffer, and the buffer length. Now we check if success is not equal to 0, which means it's not successful. Then again, we've got to indicate an error. So we can just copy these 2 lines of code and bring them in here. and change this to SDL Q audio. Okay. If SDL Q audio is successful, then we'll call SDL pause audio device, sending in again the device ID and 0 for the pause on parameter, indicating we want the sound to be unpaused. That's it. Now, once we are done with the buffer, we need to free it. So that'll be SDL free wave and pass in the buffer. Okay, so I hope that's clear. Now we need to call this function. So first come to the function egg hits enemy. And just before this return statement, we will call load sounds, sending in the file pop.wave, and that has to be in quotes, of course. This file you will find at a link in the description of this video. Make sure to copy that file into the project folder. So that takes care of a sound effect when the enemies are eliminated. Now for when the defenders eliminated. Right, so here this is in the function fire enemy ammo. So just after this, we'll call load sounds, sending in the name of the file is tumbling.wave, and again remember to copy this file from the link in the description of this video into your project folder. So that completes the sound effects. Now about the backdrop. So let's go right to the top. For the backdrop, first of all, we need a texture. So here we'll put in star backdrop texture. Now we'll initialize this later. We need a function to manage the backdrop. We're going to have the backdrop slowly moving from the right side of your screen to the left. Let's put that just here. This function is not going to return anything, so void loop backdrop, no parameters, so void. Within this function, we will have an if statement, and we will count down a variable which we will introduce now. Backdrop x is less than negative screen width, then backdrop x will be equal to 0. Okay, now we need to declare this variable. So at the top here, that will be an integer. So you put in backdrop x, and that will be initialized to 0. So that completes our loop backdrop function. The next function is to actually draw the backdrop, right? So let's put that right above this one. And that's not going to return anything. So void blit backdrop, no parameters, so void again. And here we'll have SDL rect destination, and then we'll have integer x. Now for x equal to backdrop x, and as long as x is less than screen width, x plus equal to screen width. Okay, and then within this we will set destination dot x will be equal to x, destination dot y, the O will stay as 0, and then we have dest dot width equal to, that will be screen width, and dest dot h equal to screen height. And then of course we need to call SDL render copy, passing in arguments app.renderer or texture, null to indicate we want the entire texture. Where we want it is at dest, or the position indicated by dest. So that completes this function as well. Now we need to call both these functions and of course initialize our texture as well. So come to the main function, and here we'll have backdrop texture equal to load texture. And we need to pass to load texture the file and its path, and that's backdrop.png. Again, you will find this file at the same link where you found the sound files. Make sure to copy this file into your project folder. Now to call the functions, after prepare frame, we'll call loop backdrop, blit backdrop. And that's it. Let's run this now. So here are the sound effects and the tumbling sound effect. Now one thing we need to change is, you can see this purple background there, so we need to change that. So come back to the code and we change this one to enemy bunny 3. Again, you will find this file at the same link in the description of this video where you found the sound files and the backdrop as well. And then this is rabbit 3. Okay, so what I've done is, for both these images, I've removed that background. So essentially we have a transparent background. Let's run it now. And there we have it. Okay, that ends our session and the series. Till the next series, take care. Bye.